Hello all. Today we will discuss how to interface a stepper motor with the 8051. So a stepper motor is a brushless synchronous DC motor. It has many applications in the field of robotics and mechatronics. The total rotation of the motor is divided into steps. The angle of single step is known as stepper angle or step angle of the motor. Mainly, there are two types of stepper motor available. They are unipolar and bipolar. In this demonstration, we will use a unipolar stepper motor. A unipolar stepper motor can be used in three modes. They are wave drive, full drive, and half drive. And each drive has its own advantage and disadvantage. For example, in the case of wave drive, we are only use one electromagnet to energize, so power consumption is low. In the case of full wave mode, it has more torque but power consumption is high. Similarly, we can use different modes for different purpose. Today we will discuss full drive mode. In this mode, two electromagnets are energized at a time. So the torque generated will be larger when compared to wave drive. As we told earlier, power consumption is higher than other mode. We can see four coils for a unipolar named as A, B, C, D. We can energize each coil or each electromagnet. In the full wave mode, we will use two electromagnets at a time. Here is the sequence for full wave clockwise mode. For the first step, we should give 0 0 1 1, that is 3. So for the next step, the step angle is designed according. Okay. Then the second step, we should provide 1 0 0 1, that is 9. Then for the third step, we should provide 1 1 0 0, that is C. Finally, 0 1 1 0, that is 6. So we should know this sequence: 3 9 C 6. Similarly, for an anti-clock rotation, the first step should be 1 1 0 0. Then second step is 1 0 0 1. Then third one is 0 0 1 1. Finally 0 1 1 0. So now let us design a circuit. Here we are using Proteus for designing and simulating the circuit. Okay, now let us add components one by one. First, let us add the microcontroller. We are using 8051 microcontroller for here. So 8089C51. Then the second component is motor, that is unipolar stepper motor. You can see the two type of motor. One is unipolar, then bipolar. We are using the unipolar motor. Next we can add, okay, we cannot possible to interface a stepper motor directly to 8051 because that motor require more current. So we need to use a okay, we cannot interface a stepper motor to 805 directly. We need to use a ULN 2003 IC. So next we can add ULN 2003. The other components are, we need a crystal, then some capacitor, then one resistor. Now one more, we need a 12 volt supply, so let's add one battery. Now let us go to the wiring. So first we can add 8051 to the workspace. You can see here. Next we can add crystal and reset circuit. So crystal, here I am adding the crystal. So crystal is connected across 18 and 19. Then 22 PF or 33 PF capacitor should connect to crystal and other should connect to ground. We can change this property. It's 22 PF. Here also 22 PF. The other end should connect to ground. Then let us go to the reset circuitry. Here is a reset. So always we should provide some active low signal. So let us put one resistor over here. Then to connect to ground, Here we can use a 10 μF capacitor. So when the circuit is turned on, the capacitor charge. Now the crystal and power supply part is over. Next we can use stepper motor and UALN 2003, that is current driver. I am connecting this UALN 2003 to port 2. Here is the 4 wire. Then let us add stepper motor here. This is the unipolar stepper motor. So there is a display to understand the current angle. Let us change its property. Here step angle is 90 degrees, so we can reduce it to 1.8 degree. So one of the property. Then let us connect all the windings. The sequence may change if we connect to different place. Now we have one common connection. One supply is provided to that. So a 12 volt supply used here. Now it's a 1.5 volt. We can change to 12 volt. So positive should be connected to COM pin. The other point should be grounded. Okay, now our circuit is completed. The next step is to write program for the stepper motor interface. For this purpose, let me use Keil because we are using 8051. So key is the IDE. So let us start a new project, new microvision project. Let us add its name. Here we can select the IC 8089C52. Here we can write the code. So let's add one new file. We are writing a C program here. So main.c. To interface we need two header file, that is reg52.h similarly stdio.h. Let's start the void main. Inside we can write a while loop. Okay. In the circuit diagram we have used the port 2. So we are giving the signal to port 2. So P2 equal to, the first signal is 3. 3 in terms of hex, 0x03. Then next one is 6. Then third one is C. Then fourth one is 9. We should add some delay between these signals. So now let us add one delay function. Void delay then now the delay function is declared. Next step is we can add its definition. So void delay we can vary the delay. Actually we can adjust its speed using this delay. Here I am using two for loop. First for loop with I condition, I equal to 0, I less than k, I plus plus. Inside we can add one more for loop for j equal to 0, j less than 100, then j plus plus. Delay function is completed. Now add this delay between these signals. Delay 1000. We are providing a 1000 delay. We can precisely calculate the RPM using this delay function. Now I just add one random delay. The C file has been saved. Then we can add to our source group. So I am adding x16C files to group. Has been added. First let us compile. There is one issues. So let us remove this error to get correctly. Okay, now the code is okay. Next step Next step is to generate a hex code from here. So option for target. Check this hex file, create hex file option. See, our hex file also created. Now we have one circuit and hex file. Next step is programming. I have add stepper.hex file as a program file and click OK. Now let's run the file. Now you can see the stepper motor is rotating. We can increase the speed by either by increasing clock speed, otherwise we can reduce the delay. Now the stepper motor is running smoothly. One advantage of this stepper motor is that we can precisely control its position. In this way, we can interface a simple stepper motor with the 8051. Thank you.